My name is Yuri. I'm Principal Technical Account Manager at AWS Enterprise Support. I'm also leading Cloud Intelligence Dashboards project at AWS. And today we are going to talk about generative AI workloads and how to maximize cost efficiency of your generative AI workloads. So let's kick off. Let's begin. For this session, I'm going to focus mostly on cost effectiveness of workloads which we run in Amazon Bedrock. And for pretty much all of you probably know that, but Amazon Bedrock is a fully managed service which we offer, in which we offer a choice of high-performing foundational models from different leading AI companies. We have our own models, we have partners like Anthropic, Meta, and we also, in Bedrock, we provide a broad set of capabilities which you need to build generative AI applications, simplify development, while actually maintaining cost efficiency, privacy, security. So when we work with customers on maximizing the cost efficiency of generative AI workloads which run in Amazon Bedrock, we usually identify this kind of key strategies or key directions where you need to focus on. And first is model and pricing option selection and the cost trade-offs. We are going to talk about each of them in details, but it's very important to understand that those choices matter and matter significantly. Being able to reason about which model should I use for my particular use case, when and I should use particular pricing options in Bedrock. It's very, very important. It's crucial. Next, we cannot speak about cost efficiency without being able to understand how our cost and usage looks like. So cost and usage visibility, ability to measure your usage and cost of generative AI workloads, it's also crucial. And not just measure, but also make this visibility available to pretty much every stakeholder in your organization, starting from developers to FinOps teams and to also leadership stakeholders. So it's very important. Another aspect of and another strategy which should be well considered is the governance around generative AI workloads, and we are going to talk about this later as well. So how you approach governance of your workloads to make sure that you stay within the budgets, you can react to unexpected spikes, you can predict the cost and usage of your workloads, etc., etc. Then another area which requires quite significant investment of understanding is token-based pricing and token-based consumption, and actually your token usage and what we can do to optimize the usage. Because in Amazon Bedrock, you actually it's pay as you use pricing model. So more you consume tokens, more it costs, right? So if we want our workloads to be cost efficient, we actually need to understand how we can get the maximum business value out of the token, right? And in generative AI workloads, it's very, very important to approach optimization at pretty much all the cycles of your software development life cycle, and seek for continuous optimization opportunities from the beginning, from the POCs, and throughout the life cycle of the project. And one of the most important parts is you need to define some measurement of criteria for success of the project. How you define the KPIs, how you define and measure your return of investment for generative AI investments. So this is also crucial to be able to set those criteria and make sure that everyone in your organization understands, who involved in generative AI workloads, understands those criteria. And we are going to cover this also later in the presentation. All right, let's start with basics. And in order to understand the token-based pricing model, let's first quickly speak about what is a token. And token, it's a fundamental unit of text representation, which is used by generative AI models, right? It's very different from traditional workloads, which are usually like resource-based utilizations, such as vCPU consumption or storage gigabyte consumption. So here we're talking about token-based pricing. Yes, so we are charged by the usage of tokens. And if you take some one page of Jeff's letter to shareholders, we can see that roughly it's like around 716 words, which translates roughly to 950 tokens. So you can have some rough prediction of text to tokens translation. It's basically like 750 words. It would be around 1,000 tokens, but there is not much sense to predict or try to estimate like that amount of tokens. I will explain why. It just the reason why I'm telling this is just like for everyone to be on the same page, that kind of more input text will generate more tokens. So it's kind of proportional, right? And the process of conversion or breakdown of text to the tokens, it's called tokenization. And why I said that it doesn't really make sense to roughly estimate the tokens, because the tokenization is LLM specific. So the same input for different models will result in two different number of tokens. So if you want to actually understand what amount of tokens you need to kind of generate output for given input, you need to test it actually with particular models that you want to use and to get precise number, right? And if you test it with one model, it doesn't really mean that it will be the same number with another model. Why it's important? Because you charged by input and output tokens. So by measuring the amount of tokens for your inputs, you can estimate basically the cost, and you can see what you can possibly optimize. So it's kind of a starting point for everything, for understanding the baseline of how much it's going to cost you, understanding like what you can possibly optimize. So here is pretty much your starting point, because the cost is based on the input and output tokens. All right. Now let's talk about choosing the right pricing option and choosing the right model for the job. In Bedrock, we provide several pricing options, and we start with on-demand inference. And on-demand inference is probably the place where everyone will start. It's great for prototyping, for POCs. It's pretty much you pay for every input token processed and every output token generated. So if you don't send your request, you are not paying. You're paying only for input and output tokens which you send. So it's really consumption based. On-demand inference, when you run on-demand inference, it's basically it's run on, you can think of it as run on shared infrastructure, right? And that's why you have some. It's great to get started, but there are some aspects that you should be aware of, because it runs on kind of shared infrastructure. There are some requests per minute and token per minute limits or quotas enforced. Yes, so you actually can use this on-demand pricing model until some point, until some performance or throughput which you need reached. And those are the limits which you actually kind of you can achieve. After that, you either can use something like exponential backoff, because your request might be throttled, or will be throttled, so you can handle it in your code, or you can consider using things like provision throughput. And with provision throughput, you actually reserve throughput, so you kind of have like dedicated reserved kind of chunk of infrastructure to run your inference. When you provision throughput, you actually not paying now per request or per input and output tokens. You actually paying per model units which provision. So once you provision throughput, you pay for model units which you provision. And you can either have it without commitment or have commitment for 1 or 6 months with reduced price, right? So you paying now on based on hourly rate and not based on input and output tokens. By default, you can provision 2 model units. We are going to talk about model units a little bit later, but you can request those limit increases if you need provision throughput. And another interesting way to kind of optimize your costs is the batch inference. So basically, for every use case which doesn't require interactive inference, like live interaction with your user, with your agent, where basically for use cases which you can process in background asynchronously, you can use batch inference, and with batch inference, you have kind of the same price with on demand as on demand, but you can aggregate and process requests asynchronously, and because of that, you can get like up to 50% lower price compared to on-demand inference. So just to summarize, think of it, if you need live interaction in inference, start with on-demand. Once you scale, consider provision throughput. If you start to hit kind of request per minute, token per minute limits. Once you have some baseline, you can also consider commitment with provision throughput to get lower price. For everything which can be performed asynchronously, you can use batch inference. So for example, if you have a task which you have like, I don't know, a bunch of some trip reports, stories, or bunch of documents which you need to process, where you don't need to have live interaction, that's exactly the use cases for batch inference. Now let's talk about different variety of foundational models and how to choose the right model. So basically, as I mentioned, in Bedrock, we provide wide variety of different models from leading AI companies. From Amazon, we have like quite recently announced Amazon Nova models. Then we have models from Anthropic, Meta, Stability AI, Mistral AI. So all these models available via Bedrock, and model selection is one of the most impactful items in your generative AI workloads if we talk about like cost efficiency and performance. Because when you select a model, basically you first of all need to look for different aspects like accuracy of the model, and like whether it provides you some reasoning capability, whether you need those reasoning capability, context window, and basically the maximum amount of input tokens which it can process, and the maximum output window, so it's maximum output which it can return. Then inference speed, the model's different by the inference speed as well, right? So how fast it can generate responses. Then some different capabilities like multimodality. So if you need to process some pictures, so images, if you need to get to generate an image, again, you need models which support it, right? And also, obviously, the pricing is different. Each model and each even model version have its own pricing. And this pricing is very, very different and very varies. Let me give you some example. Imagine that we have a user who needs to process 20 million tokens in a Bedrock foundational model and expects to generate 1 million tokens as output for text summarization use case. Quite a simple use case. So if you pick Amazon Nova Lite model, I just picked the pricing, I think for US East 1, so North Virginia region. So and I took, basically this is the price per 1,000 tokens. So I just took amount of input tokens and multiplied by price, and amount of output tokens multiplied by price. So with Amazon Nova Lite, it will cost me $1.60. If I use larger models like Anthropic Claude Instant, the same task will cost me $18. If I use Anthropic Claude 3.5 Sonnet, it will cost me $84. Exactly the same task. If accuracy is enough for me for my text summarization, if it's maybe some short story which fits to context window, like you can see that by choosing the more appropriate model for the job, you can reduce the cost by like factor of tens, right? So it's not even twice, it's like tens. Now, what tools you have which can help you to choose the right model? So first, like to get started, you can use Chat Playground in Bedrock in AWS console. And in Playground, you can actually use this one prompt and compare the answers across up to 3 different models. And when you receive the answer, you get those results, so you can compare results, and you can also see the input tokens, the output tokens, so those numbers in the rectangles, and you can also see the latency, right? So how much time it took for model to generate the output. So here you can experiment, you can run the different prompts and see how the different models respond, right? So you can compare it. If you want to evaluate the models, you can use in Bedrock model evaluation capabilities. So it allows you to implement either automatic or like human evaluation method. So you can compare different models across multiple parameters and metrics, so other predefined or custom metrics like robustness, accuracy, etc. You can use either provided built-in curated datasets or bring your own dataset. And you can actually compare the performance benchmarks of different or several models for your particular use case to get kind of understanding and assessment which model you can use, right? So that's pretty much how you can select the right model for the job. But just as if there is one thing I want you to remember from this section is that each model has its own price and the price is very, very different. So don't start with the largest models because usually they are more expensive and have higher latency. Start with like smaller models and increase if accuracy is not enough. Now let's talk about request per minute and tokens per minute. For on-demand inference, there are hard limits which applied actually, and we can call them enforced quotas. So basically, how to calculate whether you can hit those limits or not. Request per minute is quite easy, right? So you can get them from like CloudWatch. So you understand how many requests your application, your users might generate. So it's very simple, requests per minute. Now, when you have understanding of what's the amount of tokens which generated per request. So if you have some average amount of tokens per request, you can actually multiply amount of tokens by amount of requests. You will have basically tokens per limit. And why it's kind of matters because each model, as we mentioned, so each model will have a different amount of tokens for the same input, right? And those limits also, they are very different for different models. So we have in our documentation a page which actually shows all these limits which apply to each model, and it's very important to bear in mind those limits, right? Because when you run some simple POCs, you most likely won't hit them. But once you start getting into kind of more, you start getting your users or you get more into production use cases, you can hit those limits. So like be prepared, right? So either implement in your code things like exponential backoff, make sure that you can handle this in the code. Yes, so maybe have some queuing and things like that. Or you can consider provision throughput. You select amount of model units which you want to use, and it basically will represent a dedicated processing capacity which allocated to run your inference workloads. And this capacity will determine how many requests you can process. But that part will actually like depend on the exact model which you selected. So one model unit will be translated into different max input TPM and max output tokens per minute for different models. So it's kind of a bit complicated math. So if you are in the use cases when you consider using provision throughput, please reach out to your AWS representative, to your account team, to your account manager, technical account manager. They will help you to calculate for particular model how many model units you might need to use. So this part is kind of not trivial, so be aware of it. Why I'm like focusing on provision throughput here? Because you can use provision throughput to implement things like quality of service, right? Because in Bedrock, you use the single API for both on-demand and provision throughput. So into that API, you basically provide a model ID. When you call invoke model API call, you provide a model ID. And if you use on-demand inference, you just use like default model ID of the model of your choice. Or once you provision throughput, you have ARN of provision throughput. So if you specify that ARN in request, so those requests will be run against your provision throughput model. So what you can do with that is actually you can, for example, have a different tiering for different type of users, right? So you can have like premium subscription users, or higher priority for whatever reason users who will be using provision throughput model. And you can have like free tier users who can use on-demand inference. And with on-demand inference, you can have some, if you implement exponential backoff and you actually will increase your latency, maybe for free tier users is fine, right? So they it's okay in most of the cases. So it will happen only in cases when you get throttled. So you can actually have some quality of service and allow some category of users to actually have the stable performance and reduce latency with provision throughput. All right, let's quickly recap of pricing options and the models. So when you select foundational model, what matters is your prompt size, your model context window and supported context window and model max output tokens, then cost per token, right? Model accuracy, input-output modalities. So does it support text? Does it support does it support images? Does it support some audio file generation, etc.? And of course, the limits for requests per minute and token per minute. Here is a consideration for the model selection. And when you choose pricing option, again, start with on-demand for live inference, use batch for asynchronous inference, and then use provision throughput when you need reduced latency, where you need to guarantee the performance of requests and where you need to actually scale further, right? Or use the combination of them. And of course, monitor and optimize your consumption. So now let's talk about what tools are available to monitor cost and usage, right? Because to optimize something, you need to manage something, you need to understand it, right? You need to understand the details, what you have. So the first way how you can track your usage, right? And during the task invocation or during the model invocation, when you basically, here is a very small bunch of code where I invoke Claude 2.1 model. I just print response, body of response. Here is my answer, so like some summary of the text, and I have input tokens and output tokens for every single request. So if I extract those tokens and pretty much store them, I can build my own metering, but which is more important, I can have some rate limiting system implemented already. So I can also enrich my request to Bedrock with some additional context, like what is the tenant ID, what is the user ID, etc. So then, when I get this data out of my execution context with amount of tokens and store it, I can implement things like rate limiting. And again, what we just discussed, I can have some different rate limits in the application now for different types of subscription plans if I have API usage, right? Or in case of customer support chatbots, I can now also have some limit of tokens which every user can consume, and after that, whatever, either have some premium, charge some premium on top, or maybe say, okay, here's you consume all your tokens for today. So you can actually implement in your application this kind of rate limiting, and it's very important about to think about this kind of things during the design phase, right? How you are going to actually limit the usage so it stays in some predictable scale, right? So you can actually stay within the budgets that you planned for this workload. Because if you allow your users run unlimited amount of requests, to generate unlimited amount of tokens, it could also bring some unexpected surprises, right? So you can actually get some unexpected increase spikes. So think about implementation of rate limiting in the design of your workloads, right? Now, another very nice way how you can monitor usage of Bedrock is CloudWatch metrics. In CloudWatch, you can see quite a lot of different useful metrics like input token count per model, output token count, invocation throttles, when you actually start hitting those RPM and TPM limits, then amount of invocations, invocation latency. So a lot of useful metrics which you can use to assess in near real time, assess basically the usage of your workloads, how many tokens they consume, how many invocations you can have. You can build a dashboard in CloudWatch with this kind of near real time data. You can also use model invocation logs to see some like prompts which were used in the model, or to get some details about this additional context, like to build some reports of how many invocations were made by user, by tenant, and stuff like that. And this is great. And mostly CloudWatch dashboards and CloudWatch metrics consumed by the DevOps teams, by developer teams, to actually get this near real time usage. CloudWatch doesn't have cost, so, and also usually like if you run your Bedrock workloads in different AWS accounts, it's quite challenging to consolidate the dashboards, CloudWatch metrics in one single dashboard. So usually you would use it per your kind of AWS account and region to have this monitoring. You can set up alarms in CloudWatch and get notifications if you exceeded particular amount of, for example, input or output tokens, so total token counts, or if you have throttles. Again, once you have started getting throttles, you can have alarm in CloudWatch to notify you that, oh, my application started to hit the throttles. Then if you want to monitor cost or have like centralized view, you can use Cost Explorer. Everyone is familiar with Cost Explorer, and I think you can actually have a nice visibility over cost by using just by using Cost Explorer. One very interesting thing to note here that open source third-party foundational models and Amazon foundational models actually charged under Bedrock service, and like closed source third-party foundational models, they charged as marketplace product. So that's why in Cost Explorer you will see actually some usage might be charged as Bedrock and some as the name of the model, right? So, and again, you can use Cost Explorer. It's great. You can use like breakdown by usage type and see like how many input tokens you're paying for, output tokens you're paying for. So those are like this is a nice visibility. However, in Cost Explorer you cannot see the usage, right? So you can see only cost. In Cost Explorer also, because for marketplace charged models, you cannot see cost per resource, so you cannot see actually the version of the model which you use. So if you need to get additional insights, additional details, you can use Cloud Intelligence dashboards. For those who are not familiar with Cloud Intelligence dashboards, it's just a collection of dashboards in Amazon QuickSight, which we provide as a solution which every customer can deploy in their accounts. We pre-build these dashboards in a way how we think as like FinOps experts and SMEs, as technical account managers, commercial architects who work with customer every day on this kind of optimization topics. We pre-build these dashboards in a way how to find optimization opportunities quickly and easily, right? When you deploy this solution, all the data stays in your account. You don't need to share it with third parties. And the solution is quite cost efficient. You don't pay for the dashboards. You pay only for underlying services, for like QuickSight, Athena S3. Usually the cost of this solution itself, it's like around less than $100 per month. And when you deploy Cloud Intelligence dashboards in your account, you turn all the data sources from different services like cost and usage report, anomaly detection, compute optimizer. For our use case, for GenAI workloads, we need cost and usage report only. So basically, you turn them to deliver data in Amazon S3, and you get provisioned also Amazon Athena table definitions and different views to effectively query this data, right? So you can get some optimization data lake, and you get ready to be used dashboards, which also provisioned with CloudFormation templates out of the box, which pre-build actually to effectively visualize the data. So you can share these dashboards with pretty much any stakeholder in your organization. It's BI tool. It supports multiple different access and sharing capabilities. You can integrate with your IDP, with SSO portals. You can share via email. You can share via IAM integration. So it's very, very easy. So you can create this kind of centralized collaboration place for different stakeholders. And in one of the Cloud Intelligence dashboards, which called Kudos, we released, I think about a year ago, a lot of visuals which provide very comprehensive insights and detailed view into IEML cost and usage, and in particular in Bedrock. So in Kudos, you can find additional categorization for your usage. So categorization by input tokens, output tokens, image generation use cases. You get cost and usage details per model. So as you can see here, so you can see actually like for each model as resource ID, you can see not just the model, but you can also see the version of the model. With Cloud Intelligence dashboards, you can also consolidate reporting across multiple payer accounts or multiple organizations. So you can see one consolidated view. And here we actually join together marketplace charged Bedrock usage and Bedrock charged Bedrock usage. So you can see one single view for like everything all together across all your payer accounts. Let me quickly show you how it looks like. So here's a demo dashboard. So let me just share with you the link. Everyone can access it. It's publicly available, and it uses some generated demo data. So here we use Kudos dashboard, but you can access all our other dashboards as well. And here is a link if you want to learn how to deploy it. And we have IEML tab, which actually focus on IEML workloads. We have a lot of different insights for SageMaker. So if you run any workloads in SageMaker, it's not a topic of today's sessions, but actually you can explore them as well. And also let us know if you're interested in separate session for like SageMaker cost effectiveness and optimization. And if you scroll a bit down, you will find this Amazon Bedrock summary visual. And what you can get here, it's basically breakdown of your Bedrock cost and usage by different areas. So for example, you can see the cost per account, per region, and interesting like cost spent per pricing model, right? So if you use provision throughput, if you use batch, you would see them here on this visual. So it would allow you like immediately identify who is using in your organization these workloads. Then you have cost
I
per
have a question.
usage. Mhm.
Sorry
Yes.
to stop you. So we see all the dashboards are very nice. Can we see the inference time, how much it was taking for the Bedrock calls? Because
For that, you need to use CloudWatch.
okay, so what is the average response time that you are seeing till now, which you can claim? Because I see that like in AWS website it was showing something, but if I see the other vendor who is hosting the same models, I'm seeing the different inference time. So that's why I
Mhm.
want to see that
Mhm.
like what is the inference time? Like you can give us some
Yeah, yeah, yeah.
analysis.
So for that, you can use CloudWatch. So the previous method which I mentioned. So for that, you can use basically a metrics in CloudWatch, or just like during execution, you get from the response body, you get not just input and output tokens which I showed. You can also get the latency from the response. So you can just store it separately. But CloudWatch will allow you to see that. So it basically invocation time.
Okay.
Here, this dashboard is more like for FinOps team who wants to understand the like cross-organizational usage and cost. So here you can see, for example, that you have this categorization of your usage by like just in general input tokens, output tokens, image generation, right? You can break down into usage types. So you can see, oh, this is like here is like some like usage type which input token count units and stuff, but it's much harder to reason about usage types, so we created this categorization. So now if you want to explore, oh, who exactly is using image generation in my organization, you can interactively click here and you will see rest of the visuals filtered based on your selection. So you will see in which accounts it is used. So you can see daily usage by model ID. Here it's just randomly generated IDs, but you would see exact like model ID here. And you can see actually like how it looks like over every day. Um, Also, if you just unselect them, you can see the daily usage per model and model version here. Again, those are just generated IDs for the demo. And you can see that, oh, there is a spike of particular model use. So you can see exactly which model. If you select this model, you can see in which account this model is used. You can see not only cost, but also total usage. You don't have here like this average invocation stuff and things like that, but it allows you kind of to stay on top and see and identify some kind of, okay, do we have some stable pattern of usage? Which accounts use Bedrock today and things like that. So it provides you this additional nice context. All right, cautious of time, let me just jump further. So now when we have visibility, right, we have CloudWatch, we have some maybe custom reportings, we have Cost Explorer, we have Kudos dashboard. So we have a lot of tools, we have good visibility. Now let's talk about cost optimization strategies, right? And the first approach, which like first thing which you can optimize, apart from model selection and pricing option selection, is optimize token usage, right? So it's what we mentioned is how to get more business value from less tokens. And basically here it's like mostly what you can do is, if I go to next slide, here is just some tips for generating a good prompt. So basically, don't over-engineer your prompt, be clear and concise, include context only if it's needed. Be aware that more context you include, more it costs. Then you can specify and give directions about the output size, about the output formatting, and basically that's how you can also limit amount of tokens which generated. For example, you can, if you have large context, like a large story from which you need to provide categorization, summarization, maybe some extraction of key participants. So instead of sending this context and some prompt to summarize me this or categorize this, you can actually have one prompt, like send context once with the prompt, which will say, okay, I want it to be summarized, categorized, and then return me this formatted as JSON with these properties. So it will allow you to optimize the consumption of the tokens, and of course test and experiment. So like try to reduce to improve your prompts matter. Just to give you one quick example, so here's a prompt when we ask LLM like Anthropic Claude 2.1 to just tell us about the concept of cloud computing, which can be explained to a child. And it's, you see, it's two paragraphs of prompt, and it ended up with 113 input tokens and 352 output tokens. At cost for 1,000 requests, it will cost us $9. If we just use the prompt like describe cloud computing to a fifth grader in 5 sentences, first of all, it's much more concise, but second of all, it's actually tells us how we would like to limit the output, like it should be 5 sentences. And in this case, we have 23 input tokens and 111 output tokens. So we already get like 30% less cost by just optimizing the prompt. Now, where it leads us. So if we can optimize the prompt, we can implement technique which is called input preprocessing. So for input preprocessing, basically what it means that if programmatically you can you can take the prompt from your user and apply some preprocessing. So you can either remove things like redundant text, maybe new lines, some double spaces and things like that. So just to reduce its size. You can also amend this prompt to add some directions about how you want to format output, how you want to restrict output, right? So that's how you can actually like optimize the prompts on the fly. So let me give you an example. If we decided to send HTML table with some numbers in it, and we asked LLM to summarize it or like basically provide us some summary and calculations based on the data, we will end up with like 16,000 of input tokens, right? Which on 1,000 runs will cost us $130. So it's very, very large input prompt. If we pre-process this prompt and we extract CSV data or out of the prompt, or we just like process HTML and process HTML table, like we convert it to CSV. So in whatever way, we just pre-process this prompt and make it concise. So if we, let's say, assuming that we have a CSV now here, we will have now 1,700 input tokens, right? And it's like $17 instead of 130. So it's 87% less. If we now remove from this prompt all the quotes and like special characters like dollar, we know that it's in dollars and stuff like that. So here is the next prompt which we use. It will be even less, so it will be $10. So you see, like by pre-processing, by removing unnecessary parts from the prompt, you can actually significantly reduce the cost and improve kind of value per token. Another technique which you can apply is chat history optimization. If you have a use case for this interactive live chats, right? So what usually you need to do is when your user provides new prompt or agent provides new prompt, you need to take a recent chat history, like initial prompt and chat history, and send it to LLM. With the growth of like if chat is long, your input becomes quite big, so it ends up with significant cost. Or in some cases, it can actually increase the maximum context window, right? So what you can do is trim older messages and just send the recent messages, and you can choose what would be your context window. Either just use the maximum context window supported by LLM, or you can just reduce it to reduce the cost, right? It's quite easy to implement because we just can remove the older messages in your code. As a downside, it will lose some historical context. If you want to reduce your input size but still kind of have the historical context, you can implement chat summarization technique. So basically, instead of sending the whole chat history with the new prompt to LLM, you can summarize chat with additional call to LLM, have a summary of the chat history, and send a summary and a new prompt, right? So summary will be concise. It will still have some context of historical messages, so you won't drop them, and you can actually reduce amount of tokens which you consume, actually processed by LLM. Another technique which you can apply is prompt caching. So if you have users like who have similar or same prompts, you can cache prompts and results and check in your application whether this prompt available in cache. And instead of every time going to invoking LLM model for user request, you can retrieve this information if it's available in the cache. But this would allow you to actually significantly also reduce amount of times when you make calls to LLM. Another interesting technique which you can use is prompt routing. Prompt routing is actually a technique when you implement your some portion of the code which handles your user requests, and it takes a decision based on the input which model to use. So for like small amount of text, and if it's text summarization tasks, you can use some smaller LLMs which are more cost efficient, right? For something like image processing, or maybe when there is a task which requires some complex reasoning, you can use larger models, right? So basically you have like a broker or prompt router which processes the request and decides which model to use, right? So this technique is also quite very efficient. You can also use here like a smaller model in prompt router which will help it to decide and classify which model should be used in this request as well. And the last technique which I wanted to discuss is model distillation. So model distillation allows you to actually utilize smaller models which are more cost effective, and by actually teaching it. So you can increase model accuracy by teaching it from the prompts which you send to advanced model, and fine-tuning the smaller model based on the prompts which sent from your users or the predefined prompt. So with that, you can actually get your you can take a smaller model which has significantly lower cost and increase its accuracy based in particularly for your set of prompts. And as a result, you had distilled custom model which you can use to back your workloads. It sounds quite advanced, right? So it sounds quite not easy to implement. So the good news that actually we announced recently pretty much most of these techniques and features to actually help you to automate and streamline implementation of most of these techniques. So Amazon Bedrock model distillation available in preview, intelligent prompt routing available in preview, and support for prompt caching also available in preview. So stay Stay tuned. Look for when these features will be available in GA or like model distillation, intelligent prompt routing. You can try them now, or for prompt caching, you can reach out to your account teams to enable preview for you. Now, to finalize the presentation, I want to talk about governance. So because we now covered how to choose the model, how to get right visibility, now how to avoid some, cost surprises, how to make sure that we actually can stay within the boundaries which we defined for our application. Governance for generative AI workloads, the principles are very similar for like as you have for the rest of your workloads. So it's control access to the models. For each model, you can like you need to like first of all to use the model, you need to enable access to it, right? So enable only models which you use in your organizations, which you evaluated, which you plan to use. If you want to give your team some ways to experiment, maybe have a dedicated account for that, where you can have some more precise controls, maybe some more precise alerts, so where you actually know that okay, here is account for experiments, but for everything else allow only models which you evaluated, which you want your engineers to use in your organization, right? Implement pretty much least privilege principle here. And you can use IAM also to allow particular users, particular role access to particular models. Then provide these cost monitoring tools, make them available to your engineers, to your FinOps teams, make sure that everyone is aware how to use it and how to track it. Because Bedrock cost and usage is basically Bedrock cost is consumption based. You need to kind of continuously monitor your workloads to make sure that this consumption stays within the boundaries. And for that, you can set some budgets, right? Even if you don't know how much your project is going to cost in the future, you run some POC. Just put some random budget, create a budget in AWS budgets, and make sure that you have some alert set up and you set up some notifications. So when you're about to reach that budget, you will get some notifications. So it won't be a surprise for you at some day that apparently we have some chatty users which started to use it much more efficient, much more often. Um, Also, like very key part of maximizing the cost efficiency and governance is establishing cost allocation and have this tracing and ability to trace your consumption to the features, to the use cases. And generally for cost allocation, so you can use pretty much uh, common techniques, like, for example, you can have your particular use cases for Bedrock run in different AWS accounts, and it will significantly simplify your cost allocation in the future. So if you know that, okay, this application has Bedrock API available in this particular account, and another application in another account, so you can simplify the cost allocation. If you have them in the single account, you can tag many things in Bedrock, but unfortunately you cannot tag invoke model API calls. So you cannot actually tag them to quickly and like to understand from cost and usage details which feature is using that model or those invocations or which user. For that, you need to implement things like tracing. So you need to add additional context in your request, like tenant IDs, user IDs, and actually use things like CloudWatch logs to be able to then aggregate amount of requests per user and maybe export those logs to S3 and built in your cost reporting system. So for example, with Cloud Intelligence dashboards, you can add additional data sources from S3 and enhance your reporting with some additional metrics. Then very important is have some cost anomaly detection in place and alerts, right? Because budgets, it's one thing, so you set some threshold boundary for your usage, but what if there is unexpected spike which happens within your budget? Cost anomaly will help a lot here. One caveat here which everyone should be aware of: we mentioned at the beginning that third-party models charged as marketplace purchases. AWS cost anomaly detection doesn't cover marketplace. it's very important to know. So if you run third-party models, your AWS cost anomaly detection won't cover them. And we have a feature request open for service team, but meanwhile, it just be aware of that. As a workaround, you can use cost anomaly within the CloudWatch billing metrics. So on your organizational account, you can set up cost anomaly detection on the billing metric, which will cover your organization, and the billing metric could cover actually your marketplace spend. So be aware of that and make sure that you have cost anomaly detection in place. And of course, define KPIs to measure return of investment. Yeah, make sure that you actually can measure the impact of your generative AI workloads on your revenue, right? And or on your some different like proxy metrics. So for example, you can measure impact of your generative AI workloads and use cases on things like customer satisfaction score, like reduction on support tickets, or maybe like uplift from AI generated recommendations or some time and efficiency savings, right? So make sure that you have a plan what and how you're going to track, because there will be a cost associated with generative AI workloads. So you need to understand whether this cost actually justify your business impact or not. And for that, like think about these KPIs in the initial phases on the project rather than, like, okay, we ran it for a lot of time, we see significant cost, but we don't understand, like what the impact it makes on the business. And of course, some things like if you have tracking of cost per business driver, you can actually also understand like cost per customer or cost per user. You can understand what impact your generative workloads make on your cost per customer to then compare it to this proxy metrics to understand whether it actually has like what value it brings to you, right? You can also track cost per some query or cost per useful response. And in this case, it's another interesting idea is to implement feedback loops in your application so users could rate the answers of your basically your generative AI applications, rate each answer, and then you can analyze, okay, what's the ratio of good answers from the maybe not satisfactory answers, and at the end you can analyze what was the cost per useful response, right? Not just per all responses, but per useful responses. So think about those KPIs, approach your GenAI workloads with good governance principles, establish these governance principles, and always continuously think about optimization and what you can improve. So it's not a project, it's a process, right? So maximizing the cost efficiency, it's continuous process of improvements. So at every stage, think about optimizations. With this, I'd like to thank you so much for joining today. We just closed in time, so I'm happy to stay like 5 more minutes to answer the questions. But I'd like also to ask you, please scan this QR code and let us know what you think about this session. If you want to see more sessions like that, please rate this session, and your feedback would be very appreciated. And let us know what else you would like to hear about, what other types of workloads and what other optimization techniques. We would be happy to run these events in the future. Thank you so much, and let's focus on the question.